So, before we start, go check out Carnivore Land. Release date is 15th of September. You will find, of course, a link in the description below. Now, onto our controllers last time. Now, this day, we will actually, I've kinda changed my mind about how I want him to move. Okay, so we will actually make it more, make him look better, even though we do not have the greatest animations right now. Okay, we will see that we can simply, we will work a little bit the logic behind the movement, and of course we will use the arcade to make our character aim around and stuff like this. And as always, if we had better animations, then we wouldn't have problems like this. And I'm going to, in the end, I'm going to mention what types of animations you will need, or what exactly their problem is right now, and they do not work as we wanted, so that you will know if you are making or buying them, or you have a dedicated animator, so that you will avoid stuff like the thing that just happened right now. Okay, so last time we created our character to move around and saw the basic way of how can we jump. Today we will work a little bit with the animator once again, and we will see a way we can make him move only by using the IK system. Now, if you have a different IK system than the built-in, which is, there are some in the asset store, of course, it will kind of make your life a little bit easier. So, but I don't want to use third-party assets, as you know, so we will see of a way to create something like that, and actually create something that looks good and it feels like it has too much pretty good control. So let's see our animator and the changes we had to our animator. Now, if you remember last time, we still have the same our same states over here: the locomotion, our jump start, our jumping when we are there, that is the blend tree, and when we want to get up. Now, on our locomotion, we previously had only 3 states: the idle, the walk, and the run. Now I've added more animations, and I've actually made it 2D freeform Cartesian, and added both parameters. So in script I've changed a bit how we pass the values, and because these are all from the raw mockup animations from the asset store, they only had good walking animations, so it's basically, so they will have to do for now. Now, as you see, you will see some state animations that have some unique values. For instance, the diagonal B, which stands for backwards, is when both values are minus 0.5. I want him to play a different animation than just simply lerp between the two positions, and that is why, let's see why I'm doing it this way. If I remove it, you will see that when they are both values are on the minus 0.5, you see that the lerping and the blending between the positions, well, it makes him look horrible. Okay, so in order to fix that, we add we want him to play another animation when all the values are minus 0.5, and that will be to walk diagonal backwards. Okay, that's simple. And I've also added a new float, which is the pivot turn, and for that pivot, and we use that float on inside our blend tree on the idle state, which is basically a blend tree of its own. We added this blend tree will blend with it's a one directional blend tree, okay, with a pivot turn, and which this thing, the only thing that basically does is make him rotate around, okay. And this we use it for purposes like, so if the angle is great, if the angle of the where our transform is looking is greater than a threshold that I've given him over here, you will see that he will turn and look towards the camera, okay. And that's basically our blend tree with the pivot turn float. That's what it does, okay. Now on our animators over here, I've also added a new state machine behavior, which is the prepare to jump, and the only thing that it pretty much does is add takes the transform from the animator and then gets the player control script, which is the one we wrote on a previous video, and then a new boolean we've added then turns it to false, okay. Now let's see, well, basically let's start with the scripts, or better yet, let's start with something else. Now the way the IK works is by having one transform for our hand IK and one transform for our elbow IK, okay. So this one we play over here. So if I hit play, let's unmaximize that, let's go to scene, you will see that the hand is on the hand transform IK, okay. This stuff we've already done on our arcade video. So if I move him, if I move his transform around, then we can place the weapon where we want, okay. Now the elbow will control the elbow. So how we can control where he's looking is by simply making using the IK and making an empty game object, okay, inside our player transform, not inside our own rig, but inside our player's transform. And basically this script just lerps between positions and basically makes him have the makes the IK targets to have the position they need to have, okay. This is pretty simple actually, okay, it's not that hard. Now of course this empty game object is, what it actually does is simply represents the shoulder of our character over here, and it actually copies the position of the shoulder, but we don't want him to be inside the rig since we are using since it doesn't have a good rotation. Our bones do not have a rotation that we can work with, and we cannot manipulate the rotation of our bones. So that's basically how we say that where we want our shoulder to look, and in turn we will make our hand target to look, and our elbow also to look that way. Now, if I make this to face to local, you will see that this game object makes it looks where I want to look. So if I move up, you will see that we change the rotation of our shoulder over here to look towards up. So in turn, since the hand AK only has local position, since it's a child of our shoulder, then it simply works like the way it could work in real life. Okay, so it's basically the hand AK inherits the rotation of the shoulder. Now, these positions over here, now first you do not have to copy them. It's simply to copy how to say what positions we want, and we have 2 positions, and you can even add more, and of course we have some rotations also, so that we can manipulate the rotation of our hand target. Okay, and because of course this is a lot of stuff to just copy paste, I've also created a helper script that will help us store positions. So let's actually open this up. Now we need a transform, which is the shoulder we want him to track. We need a transform which will be the hand target, which is the hand AK. We need a transform to be the elbow target, and we need a lerp rate if the AK is enabled. Now of course I'm not using it anywhere right now, but of course you might want to use it. Okay, we need a class that will have all our positions. Now of course you do not have to use it on a class, but I like to be a little more organized. Okay, a debug mode so that we can debug it, and of course we need a game object. We do not need this game object, so let me delete this and delete this. So okay, so this is basically vector 3s that we can store our positions between where we want our target, where we want our hand to lerp towards. Okay, and of course the elbow, we want to save the elbow position so that it doesn't look ugly and it doesn't look like he has broken his hand. Now we fix the positions, and we simply take random positions over here. We do not care, even though since we are going to lerp it anyway. And then we want to copy the position of our shoulder. Okay, so we take the shoulder we are going to track, which is the bone from our rig. We transform it into world space, and then we simply make the position of our transform the position to copy. Now if we are not on debug mode, then we take the local position of the hand target and we move it towards either the target position 1 or the target position 2, and all this based on the lerp rate. Now as you see, I do not have any delta time, since we are going to use it based on the angles where we are looking, and well, basically based on the angles where our character is looking and where the camera is looking. The same for the rotation, even though now this is not a lerp, it simply takes the rotation from here. If you have more rotation, or if you want to work with more rotation, you will do it the same way we do it over here, but you will use a spherical lerp. And as for the elbow target, the same also. Now this for the AK shoulder handler, and for the AK handler helper, It's just a simple script and you can execute it also in edit mode. Okay, so we have a few booleans and we say if we want to store the position, get the IK handler. So we get component IK, we get the component, and if it's the hunt, if the boolean hunt is true, that means we want to save the hunt position. So we take the local position, we take the rotation, and if it's not a rotation, so we do not want to save the rotation, and we want to save the first position, then we store the target position of we make the position and we store it to the hunt target position. Okay, the hunt target position 2 if it's not 1. Okay, simply, and if it's the rotation, we store the rotation. And if it's not the hunt, that means we want to store the position of the elbow. So we get the position, and if it's not the position 1, if it's the position 1, we store it at the elbow target position 1, and if it's not, we store it at elbow target position 2. And finally, we close the store position. Now, with this script, you will be able to copy paste values without having to write them down or copy paste a lot of stuff. So, for instance, if I press play, let's say I want to fix his hand position. I'm not too happy with it. Okay, so I want him to place it over here. I can go into my shoulder over here, and I want to store his hand target position. I want to save it on the first position, and it's the hand. Okay, so if I click store position, you will see that it updates over here. Now, of course, it didn't update too much, so let's make it more something that makes more different. So if I click store position right now, you will see that it updates all the values. If I tick the rotation, then it will update the rotation. Okay, so with this way we can find all the positions, even if we have 5 different vector trees that we want to save, we can do it this way, and then simply click the gear over here, click copy component, and then I can click paste component values. Okay, and it will update all the positions over here. Now, it's pretty simple, and the way we lerp between positions is because of our animations and the way we are using him. If he's aiming forward, it looks okay, it looks pretty good. Okay, but if he's looking to the side, you will see that his hand is changing positions, and on the other side you will see that it should have lerped on a better position, and you can see over here what's happening with the lerp. Okay, if it didn't lerp between those positions, let's see let's see it once again. If we didn't lerp between positions, you will see that when he's aiming forward, his arm is extending too much, and it actually looks like it's broken. Okay, so to avoid stuff like this, we are doing the lerp. Now, if you had different IK mechanics than what the built-in IK is, for instance, if you had fabric IK, which is another way for IK, you wouldn't have to use all this stuff. But since the only solutions right now is around $100 in the asset store for something like that, let's do it this way. Now, that's basically the IK, how we handle the positions for our IK and our IK targets and our shoulder. Okay, you need to drop the shoulder off from your rig. Okay, over here for the shoulder to track, the hand target and the elbow target. Now, let's go into our player. Let's open up the player control and let's see all the changes we had to do. Now, I'm going to go pretty fast with this since we do it in the previous video. We added a boolean prepare to jump. We have jump once, rotate to look the camera direction, target turn amount, current turn amount, and boolean can move. Okay, set up the references. This pretty much stayed the same. Instead of actually triggering the jump, we turn the prepare to jump to true, the boolean. Okay, then on fixed update, horizontal, vertical, we know what this is. The store direction we want to save. Now, there was a little problem that somebody commented also that I didn't thought about. Because we were taking the directions from the camera, that meant our camera was looking down, was looking like this. When we were walking, then our character will move slower than if we were looking straight towards up. So in order to fix that, instead of taking the directions from the camera, we take it from the camera holder, which is a game object that is tracking the player's position. So in order to get the camera holder, since we have the camera, we can say we want the parent of the camera, the parent of the parent of the camera. Okay, and we get the transfer of our camera holder. So our store direction, camera holder dot right. Okay, simple. If we can move, if the anim get bull can move, we can move. Direction forward is the store direction multiplied by horizontal, and vector 3 direction sides is cam holder dot forward multiplied by vertical. If we can move, then we add a force to rigid body, direction forward plus direction to the side, and all this we want this to be normalized and multiplied by speed subdivided by time dot delta time. Now I've added it this way to be not that cluttered up like the way we had it before, and I also wanted to normalize the direction so that when you were walking diagonally you didn't move faster than you had to. We do array from the camera, straight camera forward. Okay, we get direction position from that array. We find the direction and we level the 0, we level the y to 0, and we want to find the angle between our transform rotation and the direction we want him to look. Now, if we are not preparing to jump, then we haven't jumped, so jump once equals false. Then we pass we pass values to the animator, which basically the forward is the vertical and the sideways is the horizontal, and then rotate while aiming or moving, and we pass the angle and the direction. Now this is a function that basically stores most of the stuff we did on the previous video, and we will see of course in a bit what is inside this function. And then if we are preparing to jump, then we want him to find the direction to jump to. So let's see first the previous stuff we had. Rotate while aiming or moving. We need to pass the angle and the direction, and we're saying if the angle towards our rotation and the rotation we want to have is greater than 75, then we want to rotate to look to the camera direction. Okay, so if we do not want to rotate to look camera direction, this is basically what we had before. If we have any movement and the angle is not 0, then we rotate to look towards where a camera is looking. Okay, this is what we had in the previous video. Now, if we want to look towards the camera direction and we can move, the can move is pretty important, otherwise we will be rotating when we are on the air, where we do not want to rotate. Okay, so if we want to rotate the camera to look to the camera direction and we can move, we have a target turn amount, which is 1, and I don't remember why is 1 or where am I using this. Oh yes, I remember. Anyway, so target turn amount equals to 1. So if our angle is not 0, then the rigid body dot rotation is spherical lerp from our transform rotation to look rotation and all that by turn speed multiplied by time dot delta time. Now, the target turn amount is actually what the animator will play. Okay, so for as long as the angle is greater than 1, then it will interpolate between the current turn amount and the target turn amount. So if it's at 0, it will go at 1, and the animator in turn, it will play the walking, pivot turn animation. Okay, that's pretty much it for this. It's not that hard, and I don't know if I'm doing pretty good job explaining it right now, but trust me, it just works. It's pretty simple. Now, if we want to find the direction to jump to, we are doing this since we are not anymore rotating our character towards where we want him to go. We need to find the direction where we want him to jump. Now, the simplest way to do it is this way. We want to reset the sideways animation so that it doesn't have weird behaviors, and then we pass what we had on the previous video, where the forward is whatever the horizontal and the vertical are. Okay, then we find the direction position, which is our transfer dot position plus our camera holder dot right multiplied by horizontal and plus camera holder dot forward multiplied by the vertical. We find the direction from the direction position. We find the angle once again, even though we can pass it from above, but anyway, just copy paste it. And if the angle is not equal 0 and we can move, then rotate the rigid body with a spherical lerp, transfer dot rotation, quaternion dot look rotation, the direction we want to jump, and now by turn speed multiplied by time dot delta time. Now it's important for this for our character to rotate before playing the animation. So I've just multiplied the turn speed by 2 so that I know that I have the rotation I want to move. If I remove the 2 so that I'm multiplying with the turn speed, you will see that when I try to jump, I will jump diagonally because my character didn't have enough time to rotate towards the direction I want to use. Now, I could of course add a new float, a new public float for a turn speed over here. So, but since I can just multiply this, it's pretty much the same thing. Okay, and since we want to jump, we have rotated, we find the direction we want to jump to, we rotated our rigid body to look towards that way, and the only thing that is left right now is of course to jump. Okay, so if we haven't jumped, then we trigger the animation, and then we close the jump once. Now we have this inside an if statement, otherwise because this function runs a few times, it will always trigger the jump and it will have problems. So when we were getting up from our jump, the character will actually jump again. Okay, and this is pretty much how we avoid that. And that's pretty much with the changes inside this script. So let's see all the other stuff we have around here. Animation control, and I'm pretty sure I didn't do too much changes over here. And yes, it's pretty much the same as the previous video, so go watch that if you haven't. Okay, so the next thing it's left to do is to have our IK handler for our player. Okay, we have our IK that handles our shoulders, and we have the IK that handles the player, and this is where all the meat of it all is. Okay, now reference to our animator, reference to our IK shoulder. Public floats, just so that I can tweak them from the inspector, even though I have changed the most values. Okay, these are the values I'm using, not the ones you see on the script. Our camera, where we want our target look position, our current look position, how fast we are spherical interpolating, the shoulder forward direction, our target position direction, our current position, our target position interpolation, our current position interpolation, player control, target aim weight, current aim weight, public transport, debug cube. Debug cube is basically the cube around, with this cube over here, which is just a cube, so that we can know where our character is aiming. Okay, and that's pretty much it. Now, do not use this as a crosshair. Okay, it's not that perfect, but this is actually where the bullet would fall if we had shoot mechanics. Okay, this is basically where a player is looking, where is aiming, not looking. Now, get the references, simple. Then we do array from the camera position. Okay, we want to do array cast to see what we are looking. Now we have a layer mask, and on that layer mask we have the layer of our player, which is the controllers. Okay, the layer of our player, and we bit shift it with this so that it ignores all the layers that it says controllers. We do array cast, and where we hit, this is where we want, this is where our target look position. Okay, if we didn't hit anything, then our target look position is a point upon the array and something like 100. Now we lerp our current look position is basically a lerp between our current look position and our target look position, all this by time.delta time multiplied by 10. Now we do a lerp because it has smoother movement, and if you are going to do slow motion, well, you basically need smooth movement. Okay, if we were straight up using the position without a lerp, then it wouldn't look that good. And I've actually noticed that for some reason I have two lerps over here, but anyway. So our debug cube dot position, we lerp the position of our debug cube with the current look position. Okay, pretty much the same. Now we want to find the desired rotation from for our shoulder. So we have the a quaternion of our desired rotation, and it's a quaternion dot look rotation, our current look position where we are looking, minus our right shoulder arcade base, the transform dot position. So we find the direction from our shoulder where we are looking and from our shoulder. Now the rotation of our shoulder, okay, this right shoulder arcade base is a reference to the script, okay, but since we have the script, we can reference the transform straight up without using anything else. So the rotation of our shoulder is a spherical lerp between our rotation and our desired rotation, and all this time by delta time multiplied by spherical lerp speed. Now we need to find the direction between and actually we do not need to find this. Such a good thing. Oh no, we did. So we need to find the direction between our shoulder forward direction, which is this, and I will say in a bit what this is, and so that we know we can find the angle, so we have our current look position, which is in world space, okay. We cannot use it in world space with local space, so we have to transform it. So we transform where we are looking into local space, and we find the direction between the shoulder forward direction, which is basically, since it's a direction on a local space, which is basically vector 3 dot up dot forward, okay, so it's the same. And then we find, since we have the direction, we find the angle, and we say if the angle is greater than 30, then, and we can move, then we set the target position lerp to be at 1, else to be at 0. And if the angle is lower than 30, then the target position lerp is 0. Okay, we set the current position lerp from our current position lerp to target position lerp, all this based on time, and then on our shoulder arcade base we do the lerp rate, we pass the current position lerp rate, so we basically manipulate this float over here. And now the last thing we need on animator, okay, if we are preparing to jump, then our aim weight, we want it to be at 0. If we do not want to jump, then our target aim weight is we want it to be 1. So we basically manipulate the weight. So if we are jumping, we want to close the arcade, and we're simply doing it this way. And over here we set up the weights for avatar arcade goal right hand, okay, and the rotation, the hint position, which is the elbow, and it's pretty much all the same. And finally we manipulate the body of our character, and we want him to look towards where we want him to look, and it's actually pretty low the way I had it over here. Okay, this is the values I'm actually using. Now keep in mind that if you want to use both hands, for example for rifles or for double pistols and all this stuff, then you will need all the stuff, well, most of it anyway. You will need all this stuff for the other hand. Okay, so it's not that ideal to do it. So if you are going to make a game like this, then you need good animations, and then you need an arcade system that it's more flexible than the one we currently have over here, and of course you will need better animations. Now, in order to avoid the stuff that happened over here, like if you see when I'm getting up, our character is actually looking the other way. And you see that it does a small rotation, and that happens because our animation we have over here. What did I click? The animation we have over here. Let's see it this way. You will see that the root just goes wild behind there. Okay, let's see it like this. So in order for this to be, if you had better animations, of course you will just use the root motion and do all this stuff, and you will get away with a lot more. But since we do not have, then we just use what we have. So the ideal situation for our animations will be that the root motion by itself from inside the animation was fixing itself without having to clamp on the other positions. So the animations need to, if you have good animations, as I said before, they need to, the ideal thing would be to fix the rotation from the animation, so that you didn't have to work with the code too much. Okay, so basically I think we covered everything I wanted to cover. Okay, now my main purpose for this video was to actually show you the arcade and how we can aim with just the arcade and without even using any animations that is for aiming. Okay, with a lot of work, some better animations, and well, basically more work on it, you can create actually something pretty good. But of course the animations are a big problem, and if you have good animations you can actually create something pretty good actually. Okay, so that was it for today. Don't forget to like and subscribe. You can support me on patreon.com, where with $5 or more you can get access to a Google folder where I have all the scripts. Don't forget to check out Carnivore Land and let me know if you enjoy it. And next time we will see, and we will actually do something better. But it's something I wanted to do for a lot of time right now, so I'm actually pretty excited about it. So I'll see you next time.